Okay, so this is a little presentation to run through the answers to the MYP2 first chance test. So question 1, what type of a triangle is this? Okay, well it's got two equal sides. You can tell that because it's got these two little markers on there telling you those two things are equal. And therefore it's got two equal angles as well, that one and that one. And such a triangle is called an isosceles triangle. What is x? Well, we know the whole triangle's got to add up to 180. So these two are 180 minus the 58. And then they're both the same. So we've got to do 180 minus the 58 divided by the 2. And that tells you that one of those would be 61 degrees. 61 degrees. Moving on. What type of triangle is this? Okay, well it's got three little markers on there telling you that the three sides are all equal, and therefore it's an equilateral triangle. And then of course all the three angles are equal in an equilateral triangle as well. 180 divided by 3 is 60. You might hear my daughter in the background there, watching YouTube videos. Okay, moving on. What type of triangle is this? It's a right-angled triangle. It's got a right angle in it. What is x? Well, all three angles have got to add up to 180. So 180 minus the other two gives you 42 degrees. Okay, classifying different types of triangle. A something angle is under 90 degrees, acute. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180, and then a reflex angle is one that kind of bends back on itself, and it's between 180 and 360. Question 10. This is an irregular pentagon. Draw a regular pentagon and explain how you calculate the angle. Okay, well a pentagon's got 5 sides, and starting from a particular point, we can split that up into 3 triangles. And in those 3 triangles, all of the angles are around the edge. So the angles in the 3 triangles are also angles in the pentagon. So the whole thing adds up to 180 plus 180 plus 180. So 180 times 5 minus 2. So 5 minus 2 because 5 sides, but there's a rule that says you can always split it up into a number of triangles that is 2 fewer than that. So 5 minus 2 gives you the 3 triangles that you can split it up into. And then if you want to know how much each angle would be in a regular pentagon, you've got to take that top bit, which is 540, 380s, and then divide it by 5 to figure out how much each angle would need to be. And that comes out to be 108. But generally speaking, 180 times number of sides minus 2 gives you the angle sum, because number of sides minus 2 gives you the number of triangles. Okay, so that's the explanation of how you calculate the angle. Then of course you had to draw one, which you would draw with mathematical instruments. So you could just draw sort of lots of lines of a certain length and measure 108 degrees between each of them until you come back to the start. Problem is, you're probably going to be a little bit inaccurate in doing that, and it might not kind of meet up quite when you get back where you started. So what I tend to do is draw a circle. A circle is 360 degrees. 360 divided by 5 is 72. So from the center of the circle, mark out every 72 degrees, and then just join the points up that you mark. So that's a kind of, not a cheat way of doing it, but certainly a hack. Okay, find the area of this shape and find the perimeter of this shape. Well, it's a good idea to try and split this up a bit and maybe fill in some missing information. So I've divided it like that. You could have divided it in other ways. So I've got a rectangle here. Well, it's going to be 3 here and then 3 here because of the 3 there. So it's going to be 7 all the way along there. And then along the bottom here, that's got to be 7 because it's 4 plus 3. Down the side, the whole thing adds up to 15 because it's 9 plus 6. So if this bit was 10 and this bit was 2, then this little bit in here has to be 3 to make up the 15. This bit's here is got to be the same as this bit here, which is 4. And then if the whole thing is 7 centimeters wide, as we've established here from the top, then this bit's got to be 4 and this bit's got to be 3 because they line up with these bits here, which are 4 and 3. So you can sort of divide it up and fill in some missing information. And then finding the area of the shape is just a question of finding the areas of the individual bits. So 7 times 2, that's that bottom bit. 3 times 4, that's that bit. 7 times 4, that's that bit there. 7 along there, 4 plus 3 times 4 there. And then the top bit, 3 times 6. So that gives you 14 plus 12 plus 28 plus 18, which is 72. And that's in centimeters squared. Remember, it's an area, so it's in square units. And then find the perimeter of the shape. Well, that's just a question of adding up all the way around the edge. So we've got 10, which is this bit here, plus 3, plus 6, plus 4, plus 9, plus 7, plus 2, plus 3, plus 3, plus 3. Takes you back to the start. That gives you 50 centimeters. So remember, it's a length, it's in centimeters. Okay, find the area and perimeter of this shape. Well, that is a parallelogram, and a parallelogram is just base times vertical height, or perpendicular height, perpendicular to the ground. So that 5 there is actually irrelevant. So 8 times 4, 32 centimeters squared. And then the perimeter of the shape, so it's the length all the way around, the 8 plus that's 5 plus that 8 plus that 5 gives you 26. Okay, the next shape, find the area of this shape. That is a kite. It's a kite because it's got 2 pairs of equal sides that are not equal to each other. And the equal sides are adjacent to one another. So that is the same as that. And you can tell from the 2 little markers telling you that. And that is the same as that. So that's 5. That's also 5. That's 6.7. That's also 6.7. Now I've given you the width of the whole thing as 6, given you the height up to there as 6, and the height of the top bit as 4. And with a kite, so you can imagine kind of drawing lines across the diagonals to make a kind of T shape or a cross shape. And then that would split it into 4 triangles. And then you could have the exact same triangles on the other side, filling the whole thing out to be a rectangle. So a kite is just kind of half of a rectangle. So the area of it is just a half times the base times the height. It's a half of what it would be if it's a rectangle. So a half times 6 plus 4, that's the height. 6 plus 4 there, times the width or the base, 6 centimeters all the way along there. So you work that out. A half times 10 times 6 comes to 30 centimeters squared. Then the perimeter, well, just 6.7 plus another 6.7 plus 5 plus 5, 23.4. Okay, next bit. Find the area of this shape in centimeters and in meters squared. So I'm not actually asking you for the perimeter in this question. I'm just asking you for the area in 2 different units of measurement. So the problem with this is that some of the information is in centimeters and some of it's in meters. Okay, so that's a trapezium, and the area of a trapezium is a half A plus BH. The A plus B are the 2 parallel sides, so it's basically the average of the 2 parallel sides. That's the half A plus B bit. and then h, so times the height of the whole thing, which in this case is 5. So first of all, doing this in centimetres, that's 600 centimetres there. The 11 metres is 1,100 centimetres, and the 5 metres is 500 centimetres. So to get the area in centimetres squared, I've converted the whole problem into centimetres to start with. That's always the best way to go about it. Convert the units first. So putting all of those numbers into this formula, 0.5 times 600 plus 1,100, that's the a plus b, the two parallel sides, times the height, 500. And that will give you 425,000 centimetres squared. Then the next bit, find the area, but in metres squared. So I'm just going to convert everything to metres. So 5 and 11 are already in metres. 600 centimetres is 6 metres. So it's just taking that same formula, and then the A, B, and H are 6 metres, 11 metres, and 5 metres. So that gives you 42.5 metres squared. And of course, the common misconception might be to think that there should be 100 centimetres squared in a metre squared, but there aren't, because a metre squared is 100 centimetres times 100 centimetres, which means that there are 10,000 centimetres squared in a metre squared. Okay, moving on to the next question. Find the area of this shape. Well, this shape is basically 2 half circles, so that makes a whole circle. And then a square. You can tell that's a square because it's got the 2 little markers telling you the sides are the same. I haven't actually, in fairness, put a little right-angled marker on there to tell you that it's 90 degrees. I probably should have done that, but we'll take it as read that it's a square, despite the lack of that information. So the area of the whole thing is the area of a circle, which is made from 2 halves, plus the area of a square. The formula for the area of a circle is pi r squared, where pi is 3.14159 and so on. R is the radius, and the radius of this circle, well, if that's 6 all the way across, then the radius is 3. And then the square area is just 6 times 6. So altogether that's 3.141 pi times 3 for radius squared, and then plus for the square bit 6 times 6, as I said before. So you work that all out and it comes to about 28.3 plus 36, so that gives you an area of 64.3. And then the perimeter, well, the perimeter is just the length all the way around the edge. So you've got a whole circle all the way around the edge, so you've got the circumference of a circle, but then you've got 2 straight bits that are 6, and then you haven't got the other 2 bits of the square because they're not around the edge of the shape, so it's not part of the perimeter. So the perimeter is the circumference of a circle plus 6 plus 6. So the circumference, the formula is 2 pi r for the circumference, so make sure you know those 2 different formulae. 2 pi r plus 6 plus 6, so that's 2 times pi times the radius of 3 plus 6 plus 6. So that's 18.85 that comes out to, plus 6 plus 6, 30.85, and that's in centimetres because it's a length. Okay, on to the last one. Find the area of this shape. Well, it's basically a rectangle in the middle, 10 times 4, but then it's got 2 little half circles and 2 big half circles. So that makes a whole big circle and a whole little circle. So overall, the area is the small circle area, that one, plus the big circle area, that one, plus the rectangle in the middle. So the area of a circle is pi r squared, as we saw before. What I've done here is I've done pi r squared with a little r for the small circle, and then pi r squared with a big R for the big circle, just to distinguish between them. And then the rectangle is 10 times 4. Okay, so the small circle is 4 centimeters across, so it's got a radius of 2. And the big circle is 10 centimeters across, so it's got a radius of 5. So putting all those numbers in small circle 10 times, pi times 2 times 2, pi r squared. Big circle pi times 5 for pi r squared with the big radius. And then the rectangle is still 10 times 4. So you get 4 times pi plus 25 times pi plus the 40. 4 times pi and 25 pi together, you could work them out as decimals now, but what I've done is just kind of put them together as 29 times pi, one thing, plus the 40. And then I've worked it out as a decimal after that. So 21 times pi is 91.1 ish, plus the 40 gives you 131.1, and that's in centimeters squared. Okay, so that's the area. Now the perimeter of the shape. Well, the perimeter of the shape is just the circumference of the two circles, because none of the rectangle is actually around the edge of the shape. So perimeter equals small circle circumference plus big circle circumference. The formula for the circumference of a circle is 2 pi r. And again, I've used a little r for the little circle and a big R for the big circle. So putting the small and the big radius in, so the small radius is 2, half of 4, and the big radius is 5, half of 10. That comes out to be 4 times pi plus 10 times pi. And again, I could work those out individually as decimals and then add them up, but I find it a little bit easier just to lump them together as 14 times pi and then work that out as a decimal, which comes out to be 43.98 centimeters-ish to 2 decimal places.